Okay, so here we have a number 3 of 2024 free response question. Sterling silver is an alloy that's commonly used to make the jewelry and consists of 92.5% silver and 7.5% other metals such as copper biomass. Over time, the alloy can form a tarnish of silver sulfide when it reacts with the hydrogen sulfide. So look at the chemical equation here. So the pure silver can get tarnished, and we have a hydrogen gas that's also evolved. What are the oxidation number of silver and silver sulfide? Alright, so this is easy problem. When you see silver by neutral atom, any neutral atom has the oxidation number of 0. So silver has 0 oxidation number. And then silver sulfide. Okay. Now for that, we know the molecule is neutral. Therefore, it should be 0 or for the, not silver yet. For the overall molecule has 0. Now sulfur has a -2 because it's in the next to the halogen group. And silver is simply 2x, and we're looking for the x here. So if you set x equals 1, we get 0. Therefore, the silver ion has a +1 charge. Okay, easy 1 point. Part B. The following table contains the atomic... Okay, let me actually box the answer. The following table contains the atomic radii for silver and copper. So they give us the atomic radius of silver being a little bigger than copper. Explain why sterling silver is better classified as substitutional alloy than an interstitial alloy. Now let's just recap the difference between the substitutional and interstitial. So if you look at, if you have the silver and copper, the substitutional are relatively similar size that they can simply just substitute. That's a substitutional. Now interstitial, on the other hand, you have like if you have like carbon, for example, which is small, they will go in between the space of this crystal array. Okay, so this these would be the interstitial. Now, because their atomic size are relatively not drastically different, we can just say in part BI that they have silver, the silver and copper have relatively, alright, sorry, it's pretty bad writing it. 3 in here, have relatively similar size. 165 picometer versus 145 picometer. And therefore, substitutional alloy is more predominant. And classified. Or something along that line. Okay, so part 2, using the principle of atomic structure and Coulombic law, explain why silver has a larger atomic radius than copper does. Now for this one, you need to look at the periodic table. And you're gonna notice that they are in the same column. Silver is in the 5th row, n equals 5, the principal quantum number of 5. And the copper is above that, it's in the 3D, and Ag is in 4D orbitals. So what does it mean? Remembering the periodic table trend, that if you have silver below and copper above, you're gonna get bigger size as you go down the column or family. And the reason for that is partly because of shielding effect of the inner core electron pushing away the outer electron or the valence electron. And another way I can describe it is that as you go down, you have more electron shell covering. Again, that has to do with the higher principal quantum number. So then you have more layers of inner electrons that can contribute to pushing the outer electron, making the atomic size even bigger. So you just have to explain it that way. So I would just say that silver has more electron shell because it is in 4D orbitals, 5th row, and have more inner core electron that can push the outer, or they can push or they can interfere the attraction between the outer electron and the inner nucleus, but we'll just say push the outer electron, causing the atomic cloud or electron cloud far away. Okay, I can also show you that Coulombic force, in simplest sense, that the bigger R, the distance between the nucleus and the outer electron, so you have the weaker the attraction. And so when you have a weaker attraction, it will make the atomic cloud bigger. So I think the converse could be described here. Okay. So on the other hand, if you have copper, is in 3D orbital, and therefore it has stronger attraction. Stronger attraction between the nucleus and the valence electron, causing the electron cloud look smaller. I don't think you need to describe this far, but I'm just trying to give you guys the sense, more sense than what College Board provide the answer. So causing the electron cloud smaller, or relatively smaller, compared to what? The silver. Okay, so I'm gonna move on, and part 2. Oh, that was a part 2. That was part 2, yeah. Okay, next one we have we get to calculate the amount of tarnish, the Ag2S. So the Ag2S tarnish on sterling silver can be removed until only sterling silver remains. A student weighs a tarnished sterling silver sample both before and after removing Ag2S. Okay, we got given the molar mass. Thank you, College Board. And records data in the following table. Okay, so before the tarnish removal, include the Ag2S, but after tarnish removal, we expect only the silver remain. So, assuming that only Ag2S is removed, calculate the number of moles of silver atoms removed. Okay, so I'm gonna first have to find the difference so I can find the mass of the Ag2S. So the mass of Ag2S is simply the mass after the tarnish actually, I'm sorry, the other way. Mass before the tarnish removal and mass after the tarnish removal. Okay, so this is like you have a silver and sulfur together, and here you just have a silver. Okay, so this is the one that with the AGS and AG. This is AG, so you only get to find out the amount of AGS. So 409.21 gram minus 398.94 gram. Now for cyclic row, we have a 2 decimals, so we need to keep 2 decimals. So 409.21 minus 398.94 gives me 10.27 grams of Ag2S. But that's not what they're asking. They want us to find the moles of silver atoms removed. Then we first need to convert this to the moles of Ag2S. 1 moles of Ag2S. And they gave us the molar mass 247.80 gram. Okay, we can cancel that out. And we multiply that with the balanced chemical reaction. So every 1 mole of Ag2S removed, then we are also removing 2 moles of Ag. Yeah. So it has a relationship of 1 to 2 ratio. So we write 2 moles of Ag. So you put it in your calculator. Again, we need we're gonna get 4 sig here. So 10.27 divided by 247.8 times 2 is giving me 0.0828894. But 4 sig is going to draw a line between 8 and 9 here. Because 9 is big enough, we need to round it up. So 0.08289 moles of silver got removed. Okay, so that is part C. Now part D, we have electrochemistry with a voltage and half reaction. So one of them is going to be reduction, another will be oxidation. So rhodium plating is a process used to protect sterling silver from tarnishing. Anytime they give you the plating question, they want to ask you like how long it takes to plate this using Faraday's constant. So it's coming soon. This involves electroplating solid rhodium onto the surface of a metal from the acidified solution. Oxygen gas is produced during the process. Now they told us oxygen is produced, but we have oxygen in the reactant, so they need to be flipped. Whenever you flip the half reaction, the inner cell will also change the sign. So we are trying to get this pure plating of rhodium. So we keep the top half reaction intact. So RH3 plus 3 electron being gained. So this will be reduction. And that also means it's an oxidizing agent because the neighbor to become oxidized. And our oxidation, we flip it 2 water, creating oxygen and 4 hydrogen ion with a 4 electron. Because the part 1 asks us to balance a net ionic reaction by plating rhodium from the acidified this solution, we need to keep the same number of electrons. So the least common multiple between 3 and 4 is 12. We multiply the top by 4. We multiply the bottom by 3. Now, one thing to be careful is that you're not changing the half cell magnitude. Just because you multiply by 4 here doesn't mean your half cell voltage is going to change. Now, if it was a Hen's law, it changes. But in the reduction potential, it doesn't change. But this question still asks us to find the net ionic. So you're gonna have to show full work. 4 RH3 plus and 12 electron, giving you 4 RH. And here we get 6 H2O, giving you 3 oxygen, 12 hydrogen ion, and 12 electron. Notice how the 12 electron cancel. And we just have to write everything on the reactant before the arrow, and everything after the arrow. Okay, it's a good practice for you to also state the state, aqueous for any ions, water for H2O. Rhodium is a metal, right? Because it's the one that we're collecting. And not only that, look at the Gibbs reaction. And oxygen is gas, and this is aqueous. 4, 6, 4, 3, 12. And this gives you 1 point. And please box it so the graders don't have to look for your answer. So, second part, calculate the E0 cell, the reduction potential for this reaction. I always do the cathode minus the anode, or oxidation, reduction and oxidation. So reduction, which I labeled here, is the 0.80 volt, and anode has a anode has a minus 1.2, minus 1.23 voltage. So the overall you get negative 0.43 volt, and that gives you 1 point. And the next part in D3 is asking you, based on the previous answer, explain why the process requires the use of external battery source. And because E0 cell is negative, this is not spontaneous. And for that, we can equate this to the delta G. Okay, so you guys know that N is a positive number. It's a number of moles of electron. And F is a Faraday's constant, 96,485 coulomb per moles of electron. So it doesn't, okay, these are all positive. So if the E0 cell is negative, if that's negative, negative times negative gives you positive. But if you have a positive delta G naught, that's not spontaneous. And that's the case here. Because it's not spontaneous, you need the external battery to offset that. Okay? So we'll say, because E0 cell is negative, the right side NFE cell will be positive, causing delta G not to be positive as well. Positive delta G is not spontaneous. Therefore, you need battery. External power or battery for the reaction to happen. Alright, took some shortcut, but try not to do that on the free response when you take the exam. I'm just trying to shorten the video. So yes, I could have just typed it and just give you the answer, but I'm not gonna show you guys the how I would think if I'm taking the AP exam. Alright, part E, calculate the length of time in seconds required to plate the 2.8 grams of rhodium onto a piece of sterling silver for 2 coulombs. Okay, so this is a fun part. I like this because we get to cancel out so many units. You always start with the single unit. We got the mixed units for 2.0 coulomb per second. So start with the 2.8 grams. And that's for many physics and chemistry calculations. 2.8 grams of rhodium. Now you have to go look up the rhodium molar mass. And if I look them up, okay, it should be 102.9 gram of rhodium for 1 mole of rhodium. Okay, so if you look at the half cell in the previous table, every rhodium are made from the 3 moles of electron. So I can say in that half cell, 1 mole of rhodium has is proportional to 3 moles of electron. Now 3 moles of electron, we have moles of electron, and we need the coulomb, so that we can use this coulomb per second, the ampere. Where is it? Yeah, we can use the ampere here. So 1 mole of electrons has a 96,485 coulomb. Okay, this number, the Faraday's constant, will be given from the formula sheet of AP exam. So you don't have to memorize it, but if you solve many questions, you will just know this by heart. And then we have two coulomb that needs to go underneath so that the coulombs can cancel, moles of electron can cancel, moles of rhodium cancel, grams of rhodium cancel, everything cancel except for what? The 1 second. Now they don't say 1 second, but you should know per second means just 1 second. So we have a desired unit, and let's keep our sig big. We're multiplying throughout, so that means that the least number of sig big will dictate the final answers. Sig big, I see 2 sig big here, also 2 sig big, 2 sig big, so you need to keep 2 sig big. So 2.8 divided by 102.9 times 3 times 96,485 and divided by 2. When you put all this number in, you get 3938. They ask for in seconds, so don't try to change to hours or like minutes. To keep this 2 sig big, I'm just gonna write in scientific notation. So 3.9 times 10 to the power of 3 seconds. And that should be the correct answer. You could have also written it as 3900 seconds. That's a 2 sig big, but don't put a dot there. If you put a dot there, you get 4 sig big. Alright, that's it. So thank you for watching my video. I'll continue to make the remaining 4, 5, 6, 7 in other time. Okay, if you like my video and if you found it helpful, please subscribe my channel, and if you like it, click the like It will encourage me to make more videos and give you guys more free lessons. That's all. Thank you very much.